Hello, and welcome to the podcast where friends discuss environmental policies from around the planet.
Hello, and welcome to another episode of the Planet Policy Pals podcast. I am Ajwa, and I'm joined here by my fellow co-host and this lovely person, Ala. Hey, girl.
Wow. Hello. This is the warmest welcome I've ever got. Hi, how are you?
I'm good. How are you? It's just I woke up on the right side of the bed. It has nothing to do with you and everything to do with me.
Well, I like to believe it has something to do with me, so I'm doing great now. So thank you.
Yeah, you are. This is our first episode of our second year. Are you excited?
Girl, you know I take this podcast a little too seriously. I'm very excited. This is great. I'm so proud of us. Look at us committing to something.
Look at us. Who would have thought?
Not me.
Not me. We got to do this TikTok now. We're going to have to do it.
Oh yeah, we should make it.
Since it's our new year, we're going to do another unusual thing. We are going to actually do a plug. We have an awesome app to tell you guys about. It is called Newsly. And trust me, we are not getting paid for this. But it is a revolutionary app that lets you listen to news, podcasts, and pretty much everything that you want on the internet all in one app. And it'll make you smarter because Ala actually pulled that on me yesterday. She's like, maybe if you listen to more of Newsly, you wouldn't be as dumb.
It's true.
Everything from sports, science to Bitcoin, pop culture, it is available and it reads it to you. They have trending podcasts for over 50 countries. And one of them is, of course, us because we're amazing. So you have even more ways to hear our lovely voices.
Yep. And like Ajwa said, I downloaded the app because I love reading the news and now I can have it read to me so I can just have more news even quicker. It's amazing. And there's tons of topics. So go ahead and start listening today. You guys are going to love it. Head to www.newsly.me and use promo code PLANETPALS to receive a 1-month free subscription courtesy of the awesome Newsly team. Or go ahead, download it from the iOS or Android app store. We will link it in the description and the code is on our website as well. And again, the app is called Newsly. The website is newsly.me and promo code for all our listeners is Planet Pals. Go rest your eyes and get some knowledge, you guys. Seriously.
So we are going to start this episode as well by taking an audience question. And we got a question from Kieran in New Zealand about liquid hydrogen. So they asked if liquid hydrogen is mostly made from steam methane reforming, how is it any better for the environment? So I'm just going to give you a little bit of an intro and then Ala can take over. So there's 3 main ways to make liquid hydrogen. There's steam methane reforming, there's electrolysis, which is splitting water with electricity. And the third is biomass. And researchers are exploring other hydrogen production methods. So they use microbes, they use light to make hydrogen. There's converting biomass into gas or liquids and then separating the hydrogen, which is what we attempted in our senior design. And then we have solar energy technologies are used that split the hydrogen from water molecules. So Ala, why is this bad for the environment?
Before I say that, I just want to say there's this company out in the Netherlands. I don't know why, but I was like going down a rabbit hole of environmental stuff and they actually have a really cool biomass hydrogen production process. And I thought it was really cool. If I find them, I'll put it in the show notes. So yeah, I will concede that liquid hydrogen has an environmental cost when it comes to the temperature and storage because you have to keep it at like negative 400 degrees Celsius, I believe. And you have to store it in extremely large tanks due to issues with its volume. However, if we can source it from biomass in larger quantities, or sometimes, even as byproducts of refining, even when you have that situation where you're getting it in a refinery situation, instead of sometimes when they burn it off, it's better to trap the methane than burn it, you know what I mean? And I'm a big believer in the whole biomethane situation. I really hope that we can start to do that on larger and larger scales. And as we optimize that process, I think as it gets more cost effective, that it's definitely going to be more possible. But to answer your question, the issue now is the temperature, right? Because cooling is expensive cost-wise and environmental. If we could handle the cooling, then it would definitely be a better option. But natural gas, you guys, I don't mind it as much.
Okay, she doesn't mind it, but we still would want greener solutions.
We do, yes.
So for today's episode, we are going to be talking about ozone depletion and its effect on our our planet Earth that we love so much. Since this is a What Happens When episode, we will talk about the future. We will talk about the history because Allah is a history nerd.
It's true.
And we'll talk about the policies that are discussed so that we may find solutions. Okay, so what is the ozone layer? Well, ozone, which is O3, is a molecule that is made up of 3 atoms of oxygen, and it is mostly found in the stratosphere. Right now, what is the stratosphere? I will explain the spheres of Earth in a second. Ozone is quite crucial for life on Earth. Now, why, you ask me? Well, it is a layer in the Earth's atmosphere which contains really high concentrations of ozone. Now, this layer absorbs like 93 to 99% of the sun's really high frequency UV light, which is ultraviolet light, and it is potentially damaging to life on Earth, right? Now, over 91% of the ozone in Earth's atmosphere is also present in this layer, and it is mainly located in the lower portion of the stratosphere, which is approximately 10 to 50 kilometers above the Earth's surface, which is the terrestrial ground that you see. And though the thickness varies seasonally and geographically, like you'll hear, oh, the ozone hole has reappeared or disappeared, those are very seasonal things, and I think Allah will explain those in a bit. When did we start realizing that ozone is something that we should have been watching out for? So back in the day, really back in the day, I mean like in 1839, there was this German scientist, Christian Friedrich Schonbein, and he was interested in discovering the origin of the odor that was produced by certain chemicals. And so when he was investigating all this, he kind of stumbled upon creating ozone artificially for the first time, even though it was abundant in nature. But this interest broadened significantly when they started studying the radiations that were emitted by the sun and the effect that they could have. Then a British meteorologist, G.M.B. Dobson, he developed a spectrophotometer, which is called the Dobson meter, that could be used to measure the ozone from the ground. Now, many of the instruments, they were relocated to acquire data from like a wide range of geographical points. And there are still, by the way, hundreds of these instruments that are being used in the world by the World Meteorological Organization, by Global Atmosphere Watch.
So you see, Ajwa, science history is fun and relevant.
Yes, it is so relevant for me to find out who decided to start measuring ozone. I want to know who's stopping it. But yes, but it was really cool, the fact that they really realized that this is a measurement that they should keep it in check. The meteorologist actually had a unit, the Dobson unit, which is a convenient measure of the total amount of ozone in a column overhead, and that's named in his honor. Now, without ozone, life on Earth would not have evolved the way that it has, right? Like, so there's the first stage of single-cell organism that we talked about, which is like 3,000 million years ago, talking about life on Earth, how it started. And that development requires an oxygen-free environment, right? And this type of environment existed on Earth about 3,000 million years ago. And as the primitive forms of plant life, they multiplied and evolved, they began to release these minute amounts of oxygen through photosynthesis, right? And this converts carbon dioxide into oxygen. Again, a quick science lesson. Now, the buildup of oxygen in the atmosphere, that is what led to the formation of the ozone layer in the upper atmosphere, or stratosphere, as we call it.
That's actually pretty cool.
Right?
I just love all these little things that put our Earth together.
Right? It is actually quite cool to know. Okay, now coming to, I keep talking about stratosphere. What is the stratosphere?
What is it, Ajwa?
So Earth is a multi-layered cake. It has 5 major and several secondary layers. And from lowest to highest, the layers are the troposphere. It extends from the Earth's surface to an average about 12 kilometers in height. To give you a little perspective, Mount Everest, the tallest mountain on the planet, is only about 9 kilometers high, right? So troposphere runs 12 kilometers high. This is where all the life pretty much exists in here, because all the air that we need for photosynthesis and the animals need to breathe, they all exist in this troposphere. And in this area, temperatures typically go down the higher you go. That's why you would always see like, oh, higher altitudes, it's colder. But since most of the heat is actually found from the Earth's surface, right? Now, the stratosphere, it is somewhere between 12 and 50 kilometers above the Earth's surface. This is the home for ozone layer. And because of the UV radiation, the higher up that you go into the stratosphere, unlike the troposphere, where the higher up you go, temperatures drop, in the stratosphere, the higher up you go, temperatures are higher because it absorbs so much of the sunlight. Then we have the mesosphere, which is located between 50 and 80 kilometers. It is past the stratosphere. It actually has quite cold temperatures. In fact, the top of this layer is the coldest place that is found in the Earth system. Most of our meteors, they burn up in this atmospheric layer, and sounding rockets and rocket-powered aircraft can also reach the mesosphere. Then we have the thermosphere, which is past the mesosphere. It is somewhere between 80 to 700 kilometers above the Earth's surface. There, the temperatures over here are higher because of the very low density of molecules that are present there. The International Space Station actually orbits in the thermosphere. And then after that, we have the exosphere, which is past the 700 kilometer mark, and it can be anywhere between 700 to 10,000 kilometers above the Earth's surface. It is the highest layer of Earth's atmosphere, and at its top, it merges with solar wind. And there's not really like a set kind of area where you're like, oh, this is where the Earth's spheres end and this is where the space dust or particles start. No, they're all like after the exosphere, or even within the exosphere, they are just kind of escaping. So it's not like a layer as much as you would think. But yeah, so those are the spheres of Earth. And now, since our focus is ozone, we're going to stay within the stratosphere. And in the stratosphere, one of our biggest problems I could talk about earlier, that ozone changes with seasons and with temperatures. So an example of the ozone depletion is the annual ozone hole that everybody keeps talking about. Ozone hole, ozone hole. And then we're like, oh, but it was here now and it's gone. And you're like, oh, look, we fixed climate change. No, that's not how this works. So we have this annual hole over Antarctica that has occurred during the Antarctic spring since the early 1980s. Now, this isn't exactly like a hole through the ozone layer, but it's rather like a large area of the stratosphere with extremely low amounts of ozone, right? Like, it's not that ozone depletion is only limited to the area of the South Pole. Studies have shown that ozone depletion occurs over the latitudes that include North America, Europe, Asia, and much of Africa, Australia, and South America. This is according to the US EPA. But what causes it, Ala? Why we get these situations?
So the polar stratospheric clouds, which I will be saying as PSCs from now on because it's a mouthful.
And she's too cool.
They play a central role in the formation of the ozone holes because what happens is they provide surfaces for chemical reactions to take place. And the reactions that happen, they're heterogeneous, which means that they don't mix very well and uniformly. So this leads to the production of what we call free radicals. And in this case, it's free radicals of chlorine. And they stay in the stratosphere. And when you have free radicals of chlorine in the stratosphere, because ozone has 3 oxygens, chemically, free radical plus 3 oxygens, it's going to destroy the ozone by trying to cling to some of that oxygen. And so that's not really a great thing to have. And then scientists recently discovered that these PSCs are occurring with increasing frequency in the Arctic. So at first we were like, we're going to close this ozone hole, and we still might. Honestly, we're on track. But the problem is that because of extreme differences in temperatures, in the cold is when these PSCs form because of water vapor that settles. And then when it gets really cold, it makes the PSCs form. And so as we continue to see extreme temperature differences from when it's warm to when it's cold, we are expecting that this frequency will continue. Another thing, the most popular thing people talk about when you hear about ozone being depleted are the ozone depleting substances. There are a lot of chemicals. I'm not going to list all of them, you guys. I'm not going to do it.
Okay.
The biggest ones are the chlorofluorocarbons, the halogenated carbons, which are called halons. Whenever you hear CFCs, that's chlorofluorocarbons. The hydrochlorofluorocarbons, which are the HCFCs. Of course, the bromides of different types. And these, of course, are all ozone depleting substances. And the way we measure them is we use CFC11, which is given an ozone depleting potential of 1, and it's a base. So for example, bromotrifluoromethane, which is a halon, has an ozone depleting potential of 10. So it's like real bad. And then CO2, which is a naturally occurring greenhouse gas, has an ozone depleting potential of 0. But it's a greenhouse gas, so it sucks. You know what I mean? It increases like the heating potential of the earth. So most of these are gone because they used to be used in like fire extinguishers and refrigerators and and coolants and foams and fumigations and aerosol propellants. But nowadays, we do have a little bit of a problem with HFCs, which we will talk about a little bit because they're still in refrigerators. And in some part of the world, I guess HCFCs are still there as well, but not as common. The third thing, and a very interesting thing that didn't used to be much of a problem, but people think will become a problem, are rocket launches.
Thanks to your billionaires, your favorites.
Oh my God. You guys, Aja is going to start a group one day to like literally eat the rich.
Girl, I'm a part of a socialist feminist movement. What do you think?
So, rocket propellants aren't much of a greenhouse gas issue because most propellants are liquid oxygen, liquid hydrogen, or they're blended with that. So, really what they give off is really water vapor. But the issue is that some rockets tend to release alumina particles and black suits if they use things like kerosene. I'm looking at you, SpaceX.
And I'm the one shitting on billionaires.
I'm just saying, like, you know, they know what they did. The problem with this is that alumina actually aids in depleting the ozone layer because it lowers albedo by scattering lights, and it can even create little ozone holes. We're not able to reflect back sun the way we do. And the alumina actually comes from space junk. You know how like sometimes the satellites will crash or like space junk will fall off? Sometimes alumina particles get caught up in the atmosphere, which is not great. I mean, sometimes it's actually from the fuel components as well. As for the soot that can come from the kerosene, guys, I just want you to think about this. We've talked about smog. We've talked about having carbon particles in the air so many times. You know, it's not great. And I just want to point out, in the interest of fairness, that SpaceX doesn't just use only kerosene. They use a blend of kerosene and liquid oxygen because kerosene is more stable, it's dense, and it's cheap. And liquid hydrogen, like I said earlier, is kind of a bitch to handle temperature and transport-wise, which we already said. But I really feel like they need to use all their technology and advancement to start figuring out ways to increase that ratio to more liquid oxygen, if you know what I mean. And then the very last thing is nitrogenous compounds. I'm talking about nitrous oxides specifically. It's weird because nitrous oxides are a greenhouse gas and they're the worst after CO2 and methane. They didn't even used to be a real problem until we made it a problem. But we did that with agriculture and sewage, not having proper sewage wastes programs, things like that. But the thing is, it also adds to our radiative forcing on the earth in the sense that like it deals with those chlorine compounds that are bad for the ozone layer. So it's tricky, but at the point we're at, we just have too much nitrous oxide. It's too many livestock, it's too much fertilizer, it's too much sewage, we gotta deal with it. So now I've listed some causes. Guys, let's get into the effects. Air quality. Aja already talked to you guys about layers, and she did point out we want ozone in the stratosphere. Why don't we want it in the troposphere? Because it becomes what scientists have very intelligently coined bad ozone. This tropospheric or bad ozone it doesn't go into the air directly, like up into the atmosphere, but it kind of sits here with us. And it's created when you have chemical reactions between oxides of nitrogen and volatile organic compounds. So it comes from your cars, your power plants, your industrial boilers, refineries, chemical plants, and other sources of basically any of these chemicals. And it happens in the presence of sunlight. We did talk about this chemistry a little bit. I'm going to refer you guys to the London Smog episode 28. Y'all know I will take any chance to plug an episode. So if you want to know why it's bad for human health, there you go. The other thing about ozone, when we get into really getting into this biosphere situation, if you want to know what the biosphere is, guys, listen to episode 2. Yeah, we're throwing it all the way back.
More plugs.
You know it.
Call her an extension cord at this point.
Oh my God. So let's talk about biogeochemical cycles. The first one I'm going to talk about is the interaction between UV rays and the ocean. In the ocean, the concentration of colored dissolved organic matter controls how much penetration you get of UV and short wavelength visible radiation. And this is important, right? And when I say colored dissolved organic matter, literally just any dissolved carbon in there in that situation, because the ocean really can only take in so much light. And the UVB rays are the problem, because when you have such intense UVB rays, you end up having some issues. The thing is that the UVB rays, they break down the colored dissolved organic matter, and then They penetrate into the aquatic ecosystems, which is just really bad for them. Another thing is we need the photosynthetically available radiation, the type that's useful. You know what I mean? And if we get a bunch of UVB rays, then it just cancels out all the great photosynthesis that's happening out there. Well, I wouldn't say cancels out, but it does make it more of a problem. So the uptake of CO2 by terrestrial ecosystems, which is another issue, via photosynthesis of plants and the release of CO2, via decomposition of old and decaying plant material, which is called litter sometimes, is also affected by the waves of solar radiation because it will increase when ozone is depleted, obviously. To put it plainly, droughts will increase as ozone is depleted. And as this happens, terrestrial surfaces, so like just think of like the forest floor as an example, it will lose plant materials and therefore carbon, which upsets the carbon cycle. You guys, the carbon cycle is important. And I know you guys learned about it all the way from like 7th or 8th grade because I used to teach middle school. And the other thing you have to think about is that part of CO2 usually fixed by plants, instead of getting fixed, in this situation, sometimes it gets sequestered in those litters that I told you end up decaying on terrestrial floors or like forest floors, things like that. Later, when it degrades, CO2 emissions will spike all of a sudden, which is not great for climate change. So that's what we have in those cycles. And I did talk about aquatic ecosystems. So I just want to mention two things that you know are important in aquatic systems: macroalgae and phytoplankton. Unlike phytoplankton though, macroalgae are fixed. They don't move around a lot. So they can't really avoid the solar radiation. They're going to get it when they're going to get it. And the thing is that photosynthesis processes affect these organisms. Phytoplankton, seagrass, macroalgae, they're all important because they're considered primary producers in that they photosynthesize and become major sources of food. If you lose that, it starts to affect the food chain going down the line in the ocean. And we know that the ocean is important. Another thing is that framework building corals, which are necessary, are also very sensitive to ocean warming. And as a result of ozone depletion, the breakdown of the symbiosis with the symbiotic algae can result in coral bleaching. So another thing that we have to consider, of course, is biodiversity. If you guys remember, we always talk about ecosystems on the show. And one thing to think about is that semi-natural grassland ecosystems can often host really large species numbers, but they're also known for high soil sea contents that can be sensitive when they have any kind of disturbance in the environment. So when ozone is taken up by plant leaves, this can alter the ecosystem's balance directly, because any change in the balance of plant species has serious effects, since all life is kind of connected, you know, like we're all one or whatever.
Lion King said it first.
Yeah, exactly. And since they form the basis of this food web, they prevent soil erosion and water loss, and they're primary producers just the way algae and phytoplankton are. They're also primary sinks for storing CO2. So losing plant species due to ozone depletion can be a problem when it comes to food supply for humans and animals. I know Aja is also going to talk a lot about flora and fauna, but one thing that I do want to mention is the bees, you guys, because these ozone-induced changes in flowering timing and signaling can have ecological impacts, because when flowering changes, the bees get confused, especially bumblebees, and they're so cute. And you guys know we need bees in our food chain, so like we have to do better.
They're the most important creatures.
And they're cute.
Well, speaking of the biosphere and causes and effects on life, we got to talk about humans. There's UVA light and then there's UVB light, right? Like these are ultraviolet radiation from the sun. So the UVB light causes cancer in domestic animals, which is similar to those that is observed in humans. And although most animals have like this greater protection from UVB because of their heavy coats and skin pigmentation, they cannot be artificially protected from UVB on a large scale. So it's not like you can be like, oh, but you won't be able to protect so many animals. And eyes and exposed parts of the body, they're actually the most at risk. But then we have plants as well, right? So the UV radiation doesn't only affect humans, but plants as well. Now, the excessive UVB, it inhibits the growth processes of almost all green plants. And there's concern that ozone depletion may lead to a loss of plant species and reduce global food supply. And any change in the balance of plant species can have serious effects since, like Allah said, we're all connected, we are one. So plants form the basis of the food web. They prevent soil erosion and water loss, and they're pretty much the primary producers of oxygen and a primary sink also for carbon dioxide. So we kind of need to save them.
Yeah.
So, Allah, how do we do it?
How do we save it? That's a great question. So first of all, I am so glad that we finally get to do an episode in this series where most of the policies used work and in a huge way. Last week, I did give the UNFCCC, still petitioning for them to shorten their name. That is the UN Framework Convention on Climate Change. A lot of shit.
Girl, it's not happening. Give up.
And I should. And I think I also did give them shit the week before, and they get a lot of shit on this podcast. But this week, I do want to highlight something we have mentioned a lot on this podcast, the Montreal Protocol, you guys. This one is good. You know?
Yeah, no, I love it. It's actually one of the biggest successes of the UNEP and the UNFCCC in general. And it's also pretty much the reason that CFCs are almost gone from this earth and HFCs are right up their ass when we are like, goodbye.
Yeah.
Yeah, no, the Montreal Protocol has led to the phase out of 99% of ozone depleting chemicals in refrigerators, air conditioners, and many other products. The latest scientific assessment of ozone depletion, which was completed in 2018, shows that as a result, parts of the ozone layer have actually recovered at a rate of 1 to 3% per decade since 2000.
I know.
The only part of the earth that we are actually improving. Yay, I'm so happy.
Yeah, we finally have a positive spin, you guys.
Yeah. So Allah, your history nerd wants to come out here and tell us some history about it?
I stand by being a science history nerd. It is a great thing to be, guys. I will not be ashamed.
And I will not stop shaming you.
If you remember from our very first episode, Ajwa talked about that guy who was riding his bike around. We talked about the Vienna Convention for the Protection of the Ozone Layer, which was adopted in 1985 and came before the Montreal Protocol. And the problem with it is that it did not require countries to take concrete actions to control ozone depleting substances. But then the original Montreal Protocol in 1987 was the first step in international efforts to change this and protect stratospheric ozone. That's why Ajwa said how big a deal it was. Under the original Montreal Protocol agreement, the developed countries had to begin phasing out CFCs in 1993 and achieve a 20% reduction related to 1986 consumptions by 1994 and 50% by 1998. And this was just like revolutionary because it moved pretty quickly. Plus, they had to freeze production and consumption of halons relative to 1986 levels. The cool thing about I know this sounds extra nerdy to say, but I'm saying it. The coolest thing about the Montreal Protocol is it also includes a unique adjustment provision that enables the parties to the protocol to respond real quick if there's any new scientific information, and they can just get together and agree on ways to accelerate reductions and requirements that are covered by the protocols. And then they meet and they go over this and they can apply it to any country that has ratified the agreement. Since that time, they've strengthened it repeatedly by controlling any additional ozone depleting substances and moving dates up when they need to phase things out. In addition to adjusting and strengthening the Montreal Protocol, they've also meet annually and they make a bunch of decisions, and they've amended it a few times. In fact, the latest amendment to the protocol is called the Kigali Amendment because it was signed in Rwanda in 2016, and it sets targets for every nation to phase down climate polluting HFCs, which isn't an ODS, but it is a greenhouse gas and it's problematic. It's used in cooling appliances and insulating foams right now. 129 countries, including China and India, have ratified the Kigali Amendment. Ajwa, do you want to guess who has not ratified it?
Is it the United States?
Ding, ding, ding. I don't know why they always take so long. So they have started implementing HFC phase down in America under the American Innovation and Manufacturing Act. And Biden did send an amendment to the Senate. He sent that out in 2021. But I guess the Senate has other things to do, none of which they're doing. But, you know, they got stuff to do. So we'll see when they ratify it. And that's where we're at right now. But girl, where are we looking for going forward?
Well, at projected rates that we have, I love scientific modeling, right? It's so fun to watch. But so the projected rates that we have, the Northern Hemisphere and mid-latitude zone, they will be healed completely by the 2030s. And the southern hemisphere ozone will follow in the 2050s, and the polar regions, which are kind of like more vulnerable, they will be healed by 2060. Now, ozone layer protection efforts have also contributed to the fight against climate change by averting an estimated of 135 billion tons of carbon dioxide equivalent emissions from 1990 to 2010. The continued declines in ozone depleting substances, the ODS that Ala mentioned, they are actually expected to result in a near complete recovery of the ozone layer near the middle of the 21st century.
Yay!
And like you said, like the CFCs and halons have been discontinued, they will actually remain in the atmosphere for many decades because the natural processes take way too long to get them out.
Yeah.
So even if there were no new emissions, there's still more than enough chlorine and bromine present in the atmosphere that can destroy ozone at certain altitudes over Antarctica from August to December, like we talked about the ozone hole. Now, the formation of the ozone hole is still expected to be an annual spring event. Like its size and depth are governed to a large degree by the meteorological conditions particular for the year. Now, in 2020, there were exceptionally large ozone holes over the Antarctic and Arctic, and this reflected some extreme meteorological conditions. As of the first week of August 2021, the ozone hole again reappeared and is rapidly growing and has extended to 23 million square kilometers, which was what they found on 13 September, and which is above the average since the mid-1980s.
And then I think it closed later in the year, right?
Yeah.
Really late last year.
But the specific dynamic conditions in the stratosphere in 2019 actually led to the smallest Antarctic ozone hole since its discovery, right? So as long as we keep observing it, we keep an eye on it, we just need continued vigilance and observation. And I think we can save it.
Yeah. Speaking of continued vigilance, I'm going to be straight up with you guys. It seems like we need to just keep doing what we're doing and not go backwards when it comes to ozone depletion. The next thing we have to tackle are the so-called F gases, the HFCs, hydrofluorocarbons, the perfluorocarbons, the sulfur hexafluorides. Most PFCs are gone, but some countries still have them. And although they don't deplete the ozone layer, they are greenhouse gases and they're dangerous. Like we said, the Kigali Agreement is targeting HFCs, and PFCs should be gone very soon because most countries got rid of them decades ago. The only other cause for concerns are, of course, the PSCs and these ozone holes. And I know I say this like every episode, but we do have to tackle climate change if we hope to deal with the temperature differences that cause these clouds to form. All right, so before we wrap this up, question for you, Ajwa. Why is ozone depletion not considered a major cause of climate change? How are they linked, though?
Okay, so because ozone depletion does not actually cause global warming, but they both have environmental problems that have kind of like a common cause, which is human activities that release pollutants into the atmosphere are altering it.
Fair enough.
Right? It is a state of the earth, like I said, that took 3,000 million years to form, and we're like 300 years, you're gone, right? So it's just human activity is altering it. So when we talk about global warming, that is caused primarily by putting too much carbon dioxide into the atmosphere, right? Like when we have this coal, oil, natural gas, they're burned to generate electricity because fossil fuels are our god, and we want to run our cars. But the ozone hole did not cause global warming, because the ozone layer normally blocks the UV light, and ozone hole allows for more UV light than usual to reach the surface. However, the additional energy that is added to the Earth's system from the ozone hole is so small that it can be responsible for the warming, like for the warming trends that we see are occurring.
There you go, guys. Once again, debunking another myth. Look at that. We just keep educating. So yeah, I guess the biggest thing I learned from this episode is that regulation works when you have good enforcement and follow through. And the success of removing these ODS chemicals from the ozone layer is proof of that. Proof.
100% agreed.
On a scale of 1 to apocalypse, I'm going to rank this at like a 3.5, because we're working on it. And if we can do something about agriculture and sewage and rocket launchers, we won't have as much stuff going into the air. We really need to get those nitrous oxides down, guys. We are messing with the nitrogen cycle, and you do not mess with the nitrogen cycle. It does not like that. But we can still keep it in check. What do you think?
Like you said, I think I would rate it something like 2, 3, not more. because this is something that we have realized since the 1980s. We are working on it, and we see how much of a difference it has made. Like in 2019, it was the smallest ozone hole that we've seen. So as long as we keep working towards our goals, we can achieve it, and we'll be fine. Just don't buy stuff with CFCs, guys, or HFCs. Just keep your eye out for that.
That's true. So same question to you guys, of course, as always, rank it for us. But then also, do you guys think we have come far enough that the ozone hole will close finally in our lifetime? Let us know. A lot of the stuff done to tackle ozone depletion is done by government agencies, UNEP and UNFCCC. I would like to highlight an environmental organization I like regardless. It's called Planet Aid, and it makes it easy for you to recycle your textiles, which are sold and reused in developing countries. And of course, the demand for used clothing is higher over there, or they repurpose it into something new. We love to see upcycling. The proceeds go towards developmental projects. They have like teacher trainings, child aid, farmer clubs in Africa, Asia, and Latin America. Thank you guys so much for hanging out with us. This was a really positive episode. We hope you guys are feeling some positivity in your lives. We got a new review and 2 new ratings, so thank you. But everyone else, keep rating, keep reviewing, and of course, send us audience questions. We love answering. Find us on Twitter, Planet Policy Pal, Instagram, Planet Policy Pals, and like our Facebook page. Donate to something good this week, guys. Spread the positivity, and as always, keep learning, guys.